So I've been able to selectively, if you want to call it that, carburize certain areas of a densified glass-like structure here. The sections here that are, as you can see, there's some vitrification. This was a foam piece which I densified. The layers of black sections here, this was put through a kiln cycle. They are a graphite infusion, which act as a incredibly high absorbing heat susceptor here. This was kind of a little experiment I had. I wasn't sure if it would exactly work. It seems to have somewhat done this. This has already cooled down a little bit from the first test. I did a 20-second blast cycle, 100% duty cycle. It ramped from about 60 degrees Fahrenheit up to about 700 degrees Fahrenheit in about 15 or 20 seconds. There was some localized charring, but otherwise it kept the arcs down. Normally graphite would arc just raw, but this seems to have, even in the open microwave here, seems to have consolidated to the surface and did not arc. So anyway, I have some thoughts with this. I'm going to try to I might try to just zap it together to see what would happen with a very long, maybe a further sinter cycle with this piece, maybe in a crucible or something, to see if I could, just to see what happens. So we'll see what happens there. Okay, as a test, I'm going to run just a 30% cycle for about 40 seconds. And kind of get a sense, after this is cooled down, I kind of want to get a sense of the ramp rates that we might be able to achieve, and if this is going to be tough enough for anything of use. So we were ambient around 60 to 70 degrees, and after this benchmark, I may want to try something. I haven't quite figured out what I'm going to try yet. I may try to see if metal will infuse to this if I layer it at high ramp rates, or I might want to just try to see if I can sinter something quickly, very quickly. So, lower ramp rates did not induce any sparks or anything like that. Ramped up to about 167 degrees, which is very reasonable for the time frame. And so I think I'll try something a little bit more. We'll do 20 seconds here at a 60% power level and see where that stands from the 160 degree mark. I want to make sure that there's no runaway, because that can induce some local hotspots, and I want to see if this this is distributed kind of evenly here with the way these susceptors are kind of like spaced. All right, we're up to 300 degrees on the susceptor portions, and that's evenly cooling, actually pretty good. About 300 degrees. Interesting. Okay, I'm going to let this cool down to room temp and come back whenever I think of next steps for an experiment with this. So an internet friend had sent me some of these, which are little tiny I believe, if I'm not mistaken, either 17.4 or 316L testing bars. These were not 3D printed with virtual foundry filament. These were through a different industrial mechanism. I think binder jet, if I'm not mistaken, but he wasn't exactly sure, or I might have just forgot. But either way, there is some binder. So normally you'd want to debind that and, you know, slowly over some time. But I don't know, I think I kind of just want to see what happens if I zap this thing at nuclear temperatures and just see what happens. I don't exactly know how this Susceptor is going to handle like the abuse of thermal shock, so hopefully it doesn't blow up or anything. But this powder should be safe enough. I was thinking aluminum, but didn't want to start a fire. Not tonight anyway. So try one of these. These are, you know, fairly small, and take one of these out and you know, get this loaded up in a crucible and get the Susceptor on top with some ballast and just see what happens. And it's been a while since I've kind of run through some of the basics. It's actually been a while since I've made a video. I've been out in the shop this whole time, but YouTube's kind of been burning me out a little bit, so I took a little break. So I figured I'd, you know, come back and explain some of the basics here. This is just a crucible. I make these here. I'm going to layer some ballast material, which is an AO203, and some other additives to that I kind of mix in to just get the properties that I like. And that's going to support the piece that I'm going to put in there, which is just that tiny little test bar. And from there, I'm going to take the Susceptor prototype, place it on top, and of course the part's going to be buried with another layer of ballast, which is going to cover. The Susceptor part's going to be on top, resting a little bit, facing Susceptor face down, which the Susceptor, again, is the carbonized graphite little raised areas, whatever you want to call that. And we're going to go at a gradual pace to start, with the intent to possibly remove some of the binder. You never want to do this sort of stuff without ventilation. I have ventilation here, ventilation over there, ventilation over here, carbon layer, you name it. Same thing, I'll probably be wearing my gas mask just as I do this. If I detect anything, or even if I don't, I'll probably still wear that just to make sure that I'm, you know, not breathing anything. So I want to make sure that you know, take safety seriously there. So anyway, let me get that started, and I'll show you once that's packed up. Okay, so I calculated, sorry, I have headphones on, calculated about 2.5 minutes. That should reach about 600 degrees internal at a 60% rate. We'll see if that happens. I'm just kind of going to trust that it works okay. This is just to attempt a mild debind, and then I'm just going to ramp it very high. Very fast. So we'll see what happens. After the 2.5 minutes, I'm going to just let it sit and release any gases it may, and give it a go after that. Okay, now we're gonna send it. I don't know. I arbitrarily just picked 22 minutes. At 100%, let's see what happens. It's gonna get pretty spicy in there. Alright, well, things have probably cooled down enough, so I'm gonna go ahead and just take the lid off. I'm gonna do that, and then just make sure everything's okay, and we'll pick back up here in just a minute. Well, nothing exploded. We seem to have A little bit of shrinkage area here around the ballast. It's still noticeably warm. Just tapping on that top seems okay. It's probably about 400 to 500 degrees Fahrenheit on top of here. Normally I would just let this cool down, but it's kind of late. I'm a little impatient. I just kind of want to see what happens. This isn't really something I'm looking for a production ready part. I'm kind of learning what happened down here. So the difference showed that between the post. I'm not going to call it sintered yet, since I don't really know what the properties are of that. But the difference between the post cycle Susceptor, you can kind of tell that part of this here, which is interesting, definitely is a different, not only texture but color. Some of it is not quite, so I think there's some sort of yeah, did not hold up to thermal shock too well. That cracked. Probably shouldn't be handling it, but anyway, this was just a test piece. But as you can see, all for science, right? Now we can see the inside, which is interesting. Definitely a different color and a definitely different texture than something like this. Let me see if I can get that better. Here, some of the outer portions have not been, I don't know if cured or sintered or whatever you'd like to call it. Definitely did not achieve that. So I think that's just because I just sent the temperature, the ramp cycle at 100% without really rotating the crucible too much. So a portion of that, which would be probably the right side, was affected more so from the temperature and the absorption. But it's interesting. I'm probably gonna just take a look and see what these more cured sections. As you can see, here's a good section that shows kind of like the difference between, if I can focus that. Yeah, there we go. So top section more absorbed, bottom section less so. I bet I'd wager that this upper section produces higher heats for the parts. Anyway, I'm gonna see what this if this has any structural integrity at all. Doubtful, but I will see. Magnetic. Yeah, so I mean, I think it. I mean, as far as like metallic sheen and everything, I mean, I think you could probably polish this thing, but I don't feel like this is a very like a centered part. I don't really know. The expectation of the strength for the green parts for the. For these sample pieces, but it did at least polish a little bit, just with some sandpaper and a Dremel. It looks like it was knocking off a little bit of the top layer. But I think I could probably break this. I'll see if I can snap it just with my fingers. Well, I don't really know how to explain this other than that this is a very ad hoc video. Not really scripting anything or whatnot, but I thought this might break, and I was just going to try to, snap it with my fingers. I can't. So, either the these green parts are very strong, or I'm very weak, or this is metal. I'm not really sure if I can. Let me see if I can snap one of these green ones. Let's see. I mean, they definitely have a different different look to them. You can see this is green and post microwave zapping. Let's see if I can snap this. I don't know. Never tried. Oh yeah. So here's the difference. That snapped without any problem. So that's kind of interesting. I don't know. Maybe I sintered this thing. Well, let's see some sandpaper. It's shining up, but let's see what this one does. I mean, this one was super easy to break. I can just snap these, and actually a lot of them came broken in the mail. But I am trying with all my might here, and this is actually, I don't know if this is bending or it's not breaking, that's for sure. So, I don't know, this might be sintered, which is kind of crazy. I just zapped the thing for like 40 minutes, 40 minutes, something like that. Let me see if I can bend it or break it with 2 pliers. I'm going to try to break these. I got this one here, and I'm going to try to snap. There we go. That definitely took some force with these. I could not break it by my hands. Let me see if I can do it again. Yeah, that's not breaking. Oh yeah, that was that took some effort. Huh, well, that was interesting. So, got this, as you can see, a pretty metallic part, which is kind of crazy, after just like such a short amount of time with that Susceptor. I don't really know what the temperatures reached up to, but it was clearly enough to at least center partially. And it was basically an open atmosphere, so I don't know. We'll try this out a little bit. I'm gonna check the Susceptor out tomorrow and see what the fragments do, and possibly make another revision with the same process to see if I can reproduce this and maybe make it a little cleaner. It had some holes in it. It wasn't perfect. And see what, if I can benchmark the the temperature range that this thing might be able to reach up to. Because if it's sintered steel, 17.4 or 316L, uncertain right now. If it can sinter that within about, less than an hour, it might be able to do something, more than that, or it might just be a very efficient way to do steel. So anyway, that is the end of this, and we'll catch you guys at some point.